Hello, everybody. So today we're going to be using the law of sines, and we're going to figure out how many different number of triangles can be formed given with certain information. And so you're probably thinking, number of triangles? What are you talking about, Mr. Goggins? It's one triangle. Well, let's take a look. In our do now, we have in this case triangle ABC. The measure of angle A is 30 degrees, AB is 12, and BC is going to be 7. We want to find the measure of angle C. All right, so again, we always should try to draw a diagram. And so here, okay, so since I'll make this angle A because that's about 30 degrees, maybe more or less. AB is 12, and so here's AB, make this 12, and BC is 7. Now, we don't know anything else, right? So we want to find the measure of angle C. Again, law of sines, we know that if we have an angle measure, or an angle measure here is going to be 30 degrees, 30 degrees. And so we have an angle measure of a triangle and the side opposites value, then we can figure out other parts of the triangle using law of sines. Here, angle C, we know the measure of the side opposite of C. So here we have our setup. We're going to find angle C using the law of sines. Okay, so we're going to use, in this case, the sine of A over A equals the sine of C over C. All right, and so we'll set up our proportion. So the sine of 30 degrees, puts over on the left here, over 7 is equal to the sine of C over 12. And so we're going to now take a look here. We're going to try to get a sine of C by itself, which will multiply both sides by 12. Yeah, we could cross multiply, but you know what though? Here it's probably easier just to multiply both sides by 12 and get sine of C, because the 12s divide out. And so sine of C equals to 12 sine of 30 divided by 7. Now, on your calculators, one of the things we're probably seeing quite a bit is that sine of 30 is equal to 1/2. But just in case you don't believe me, we can go to a calculator here, and we'll type in the sine of 30, and that's equal to 0.5. Okay, so just to show that to you. Now that means in this case we have 12 times 0.5 over 7 is equal to, well, 6 over 7. So the sine of C equals 6 over 7. Okay, so to find the angle measure, we're going to use the arc sine, or in this case, the inverse sine. In the inverse function, in this case, the inverse function, we remember for algebra 1, is going to be the function that kind of goes backwards. Like, for example, when we plug in x to get y, the inverse would be plugging in y to get x. So normally we plug in the ratio to get the angle to get the ratio. Here we're plugging in the ratio to get the angle. And so we type in sine -1, arc inverse sine of 6 divided by 7. Okay, and we'll go back to our calculator here. Make sure in degree mode, ladies and gentlemen, please make sure in degree mode. Okay, so to get the inverse sine -1, right above the sine, simply see -1 here, we're going to hit second sine, and then do 6 divided by 7. And now we're going to get a round off answer. Here we're going to get 59.9972887. So if we round this off, it's going to be, well, 59 degrees. Okay, so we'll round off to 59 degrees. Okay, so it's about 59 degrees. Fantastic. All right, well, there you go. No big deal. Well, let's analyze a little more, okay, with a little better handwriting. Okay, so the sine of A over sine of C equals sine of C 6 over 7. We found the measure angle C to be 59 degrees. But is there another angle measure we should consider? You're saying, well, what do you mean? Well, interesting enough, one of the things we are going to find out is that here, let's go back to our calculator, okay? And so our calculator here, let's type in the sine of 59 degrees. So let's type into the keyboard. So here we go, sine of 59 degrees, close parenthesis, and it gives us about, in this case, 0.85716730007. Again, this is a irrational number because it's going to keep going on forever. But then, is there another angle that will work out? You're saying, what do you mean another angle? Well, what if we, oops, no, oh shucks, sorry about that, ladies and gentlemen. I, again, got kind of caught up in this case. And here we're just typing into the keyboard. I should be typing on the screen. And so let's now type in sine, and let me try another angle. Let's say like I don't know, 121. Let's see. Okay, sine 121. Enter the same exact angle measure. That's kind of strange. Okay, it's kind of strange in this case. Like, wait, what? What is this? Why is this the case? What is the relationship between 59 degrees and 121 degrees? I know you're thinking. Something about geometry. Some magic numbers that come up geometry. All right? And if you guess that the sum of the angles is 180, you are correct. And just to make sure, oops, again, my big fat fingers. So 59 plus, 59 plus 121 is going to give us the 180 degrees. And these angles are supplementary. So something to keep in mind here in this case then is that we should also know that the sine of an angle is equal to the sine of a supplement. All right, and so yes, measure angle C can also be 121 degrees. And so here our notes will come up to say that for the two different angles we formed, if angle A is acute, if the measure of C is greater than measure A is greater than the C sine of A, then two possible triangles may be formed. Now, this is very, you say to yourself, what do you mean? What two possible triangles may be formed? Okay, well, let's consider this though, okay? Let's see if I can get around this here. So need a little more space. Let's consider now our original triangles. Okay, come back to here. All right, and what I'm going to do is I'm going to make a table. All right, our table will come up with the following, and based upon the angles. All right, so here we had angle A. And we had angle C and the leftovers, so here's angle B. And this angle was the given angle. And this angle was the solved angle. That's the angle we solved using law of sines. And this was the leftover angle. So you say, what do you mean leftover? Well, the given angle we had was 30 degrees. So that's going to be 30. And we solved for the other angle C to be 59 degrees. Therefore, angle B would have to be the difference of 180 minus 89. I said, well, why is it 180 minus 89? It would be 180 minus 30 minus 59. And that would give us an angle measure of, well, I believe it would be 91. Would that be the case? 91? Yeah. 91 degrees. Okay. Because 89 plus 91, yeah, that's 180. So this would be one triangle formed with the given information. In this case, that we knew that in that little a, if you remember, little a was, I believe, was 7, right? And little c was I believe was 12. Okay, so here we see that we had one triangle formed, but then we also found out that the angle is still given 30 degrees, but what if we use the supplement? Because the sine of the angle, a sine of 59 degrees is the same exact value as the sine of, and we said in this case, 121 degrees. So it could be sine of 59, but also be a sine of 121. So both angles will work out. Well, 180 minus 30 minus 121. Well, that's the same as 180 minus 151. And that would be, I believe, 29 degrees. Okay, guys, double check my math. No, sometimes I make errors. But I think it's going to be by 29 degrees. So now, that means that if, again, little a was 7, the side opposite angle C was 12, and the measure of angle A was 30 degrees, we had two possible triangles can be formed. Two possible triangles that can be formed. And so you're wondering, why is this happening? Okay, why is it happening? Let's go back to our diagram here. In our diagram, we are given an angle, one side and the second side. But this angle we have is not in between. Okay, this is actually angle opposite one of the sides. So we are given a situation of a side-side angle situation. And if you remember way back in some when we talked about triangles being congruent, that if we had triangles are to prove triangles congruent, we use side, side angle, side, side, hypotenuse, leg, or angle, side. Side angle was not a valid way of proving things. And the reasoning is going to be the following: is that if we got in this case, we could have two totally different triangles with the given information of side angle. All right, and that's why we do not use side angle. We have to use the other methods. And so let's now go to our just a way to approach all this here is that we want to keep in mind that you want to set up a table. Okay, so look at the table here. Okay, set up your table. Okay, and in this table we're going to have in this case our given angle measure. Okay, we're going to have a solved angle. Okay, and then we have to have the leftover number of degrees. And so this is where we find, well, can we come up with a triangle based upon information? And we did. We found that angle C was 59 degrees, and the leftover angle B would be 91 degrees. Then we explore in this case the possibility that the solved angle be the supplement. The supplement of angle of 59 degrees. And thereby seeing, is there enough a degree measure left for angle B to create a different triangle? Okay, and so using this table method is probably one way of being able to, this is what I try, so I do this now, one way of being able to determine how many degrees, how many different triangles there are based upon our information we have, if we have a side angle situation. Okay, now we're going to go over some more practice problems here, but this is the basic setup for our determining of whether or not how many triangles we can form. And here we found that there are two different, not same, but two different triangles. We call this the ambiguous case. Okay, so this is referred to as the ambiguous case. Now, to be ambiguous means ambiguous. To be ambiguous means it's not clear. Okay, and not clear and all. So we're not clear. We have a situation where we don't know whether or not we have a triangle, one specific triangle, or it could go one way or the other way. And so because we cannot determine what the correct angle measures are, we cannot say for sure, hey, that this must be the only triangle that be formed. And so we must determine based upon using law signs whether or not there are any other different triangles that can be formed here. Okay, so I will see you in the next video, and if you, for more practice explanation, and if you like this, please hit the like button and subscribe to the channel and hit notifications so you can know when any new videos come up on my channel. All right, thank you so much. Take care and be safe.